I believe that the schedule that you showed, and just touching the schedule part of your presentation, was a risk-based schedule, right?
Yeah, this is a schedule, yes.
Yeah, exactly. So just I wanted to know the rule base for coming up with the activity durations in consideration with the intensity of the risk. How the durations are set according to the risk intensity, and what type of approach you're using? Because normally the industry has been using the PERT, three durations approach: optimistic, pessimistic, and most likely. So what is the basis of this?
So I believe you are talking about Monte Carlo analysis, is it?
No, not the Monte Carlo analysis.
So,
I'm talking about PERT.
Okay, so for the PERT analysis, what we are doing is, this is an automated response. So we are looking at the total float, we are looking at the web of the activities, not only durations as well. Of course, we are looking at historically how the remaining duration impacted during the different updates. We have a look at the erosion of the float, if there is any. We are looking at the web of activities. Let's say, when I move on this activity, what happens with the remaining of the web? And we are looking at what's the predecessors, like, what's coming up. So, and there are a few more factors which we generally code depending on what the project is. So utilizing those, we are trying to come up with a risk score, and we pick one of the clusters which I was mentioning before. So this is not like a 3-point estimate. This is just looking at a few other factors than only optimistic, pessimistic, or the most likely in fun.
Okay, quite clear. Thank you.
So looking at the IoT, the use of IoT for your bridge inspection and for your payment management system to include in your entire maintenance regime, do you have controls in place to filter out, the outliers data that can skew your data, and 2, to make sure that the data received from the IoT are not coming from a faulty IoT?
Yeah, well, when we implement these technologies, we work closely to developers and consultants of these technologies. Clearly, it's not developed by us. So what we do together, first we decide where to implement the technology. And then after, let's say we analyze continuously the database that comes from there, and we clean it together. Because there are some, I can mention that at the beginning, we had some faults and noises coming from some different installations. We have very close to one of the bridges a military installation, so the results were not compatible at all. We were having clear corrosion with the normal values of pH in the concrete, so this cannot be. Then after we clean it and we calibrate the sensors together, and today we consider that this depuration of the data is quite reliable, till the point that 95%, I don't remember badly, it's correct. And calibration is very important, because these type of sensors are not easy to implement. When the structure is new, there's no issue. You can attach it to the steel, and that's it. No? And there are a lot of in the market. When the structure is old and you need to calibrate what you have there, it takes a lot of time. So we did this process at the beginning, then we controlled the database, and we saw the results finally. Yeah. Thank you.
And actually, while Noor is getting the microphone, Tony, are you finding the same? Because you obviously work with a lot of clients, so do you get the same sort of approaches to risk and what Daniel was talking about there?
We're talking about calibrating sensors, old and new data. The type of data that we analyze has less noise in it. If you think about a BIM model, or some of the examples like the Dewa house, or even the grading, the data that comes from that is very clean. The initial picture, the one that didn't run, the colorful one, that's a LiDAR point cloud that, we tend not to have that.
Just one thing I need to add. I didn't present it here, but we did some monitoring related to dynamics in the bridges as well. These dynamics can give you more or less the condition of the bridge at the time, if you know the properties of the bridge. So talking about noise and movements, what we saw is that the vibration frequencies obtained by mobile It correlates very well in the first frequencies obtained by excitation of the slab on site. So this is very interesting because when it comes to calibrate noises, you need to know what is the length of the bridge and what are the length of the spans, and then after you can know if the second and the third, they will be more or less in the range that you expected. But the first one is very reliable.
With Royal BAM using, and the Museum of Future, I know they use Dynamo to develop the various, permutations and of options, design options to come up with a lightweight design and optimized number of nodes. Do you know what else they use beside Dynamo?
So in the Museum of the Future, it was Bureau Happold, and that was one of the first applications, we would say, of generative design, and that was Dynamo. On the more, I suppose all the examples have some form of technology. The optimizer for grading is built into Civil 3D. The construction IQ is our platform. It's our CDE that's integrating all the BIM data, the schedule data from Primavera, and various other data sources to do predictive analysis on subcontractors' performance, on weather, on various different data sources. But Dynamo was the beginning of generative design, and that became more automated. So what you saw with the Dewa House, and even today, Autodesk has acquired a company called Spacemaker. We have kind of a modified version, an automatic version of Dynamo running generative design based on parameters that you give the model.
Great. So back to you, Daniel. With regard to the IoTs, you talked about the bridges and where you place them. Well, that's applicable to pretty much every IoT, whether it is for noise, whether it is for humidity, whether it is for cracking, what have you. Who do you engage with to properly place the IoT at the design level to make sure that it's placed in the right place for the right purpose?
No, I have to say that at design level, we don't have it. This is only, my department is in charge of maintenance and operation, but we are feeding them back because in terms of bridges, every bridge is like a world, different. What you saw here, we could see that one of the defects that we're having, one of the pictures appeared one big crack. This big crack is just over one of the bearings. So from the monitoring, we knew that that edge was not able to move properly with the variation of temperature, which we have here. Sometimes is more than 40 degrees in between the lower and the higher temperature. So this, along with the strain gauges that we have, we saw that the bearing is failing and is not well designed. So in the maintenance actions, we need to work with them to tell them, the bearing, don't repeat this one. I mean, you need to do a proper to approximate the best solution to the current situation we have.
That's
for existing bridges. And the new ones, we are feeding them, and we would like them to install more. This will be a very good thing. There's one bridge in Ras Al Khaimah. It's an arc metallic bridge. They did new, and this bridge has sensoring for displacements in the abutments. But this is the only one. We need to work more on that aspect, which in reality we need it, yeah.
If I may chime in, we have 2 case studies for smart bridges. One, a very small one in Amsterdam, where they've started to place sensors and monitor and collect the data and do the learning on where these sensors should be placed. And the other one is with one of our main consultants, Dara Group, and they have won an excellence award with us for their smart bridge that is 3D printed.
You're doing maintenance planning of highways and roads, and if I remember correctly, the planning horizon was 5 years, you said. So have you considered ever doing it in an integrated approach? I mean to say, while the roads in the municipal infrastructure are like in a commanding position, but there are other buried utilities as well in the right of way. So you do a very good model, and then you do a perfect maintenance, and then the other day, anybody from the buried utilities come and they say, "Oh, we have an intervention here." So all that money is lost. So is there a consideration or coordination, interdepartmental coordination, while doing your planning and doing the rehabilitation?
Yes, there are. In the Northern Emirates, the case is that there are different administrations, not single departments within our administrations. For example, we are dealing also with Emirates governments. So we need to tell them what is the rehabilitation plan. For example, now we have a case in which we are doing coal-in-place recycling in a road E18, which comes from Manama to Ras Al Khaimah Airport and going till Musandam. And we needed to engage with the local administrations to tell them we are going to do this. Because if we are going to do this, it's true. You need to come and do the whole maintenance as well, or substitution. We are not too much into the roads in the urban areas. We do have, but the majority of them, they are highways. So since they are highways, we have typical facilities there, pipelines, telephonic, and these facilities, typically, they don't receive too much upgrading and maintenance from the other authorities. But yeah, we do have to comply with them, yeah.
Okay, thank